The topic of this problem is Ohm's law and also using the well-known power equation. The problem itself is to determine the current and the power absorbed or supplied by the 2 kilo ohm resistor. So we want the current through the resistor and we want the power associated with the resistor, and to determine whether it's absorbed or supplied power. So to do this, we use Ohm's law first to determine the current. If we use Ohm's law and solve for the current, then we have current is equal to 12 volts divided by 2 kilo ohms of resistance. And so ultimately we end up with a current equal to 6 milliamps of current. So that solves for our current. And our current is a positive current in this case as well. The next thing we want to do is we want to determine the power across the 2K, or associated with a 2 kilo ohm resistor. And so the power is going to be determined by looking at the current through the resistor and the voltage across the resistor. We determine the voltage across the resistor using Ohm's law, but we also are using loop analysis, but we also have to use the passive sign convention. Passive sign convention tells us that the current is assumed to enter the positive side of the voltage polarity on an element. The passive sign convention is absolutely critical to determine power flow in a circuit. And so in this case, if we assume that the current is entering the positive polarity of the voltage drop across the 2 kilo ohm resistor, then we would then assign the polarity as shown across the 2 kilo ohm resistor. And so if we're looking for the power is going to be, in this case, the voltage, which is across the 2 kilo ohm resistor, which is going to be 12 volts, times the current, and the current is 6 milliamps. So ultimately we end up with 72 milliwatts of power, and it's a positive power. So if we're looking for whether it's absorbed or supplied, then we see that it's a positive power, and so we can then say that 72 milliwatts is absorbed by the 2 kilo ohm resistor.